name is William Wilks, and this is a presentation on my invention, SmartBeep. SmartBeep is a tool that interprets radio pulses from wildlife transmitters. The Department of Conservation and other organisations use data outputs from these transmitters to make management decisions for a species.
For New Zealand species, there are 20 different hardware platforms that can run 23 software versions. All must be produced in the correct combination for each species.
SmartBeep is a tool for manufacturers to ensure the correct software is put into the transmitter before shipment to the conservation field workers.
Until I invented SmartBeep, this process was completed manually, but manual checking is slow and boring and requires a high level of familiarity to detect the subtle differences between software. The data stream includes important species management information, such as how many days since hatch of eggs or whether the animal has mated. To develop SmartBeep, I had to identify the output pulses that are unique to each version of software. SmartBeep listens to these pulses and displays the data on your computer in the same format you would use to record it if listening manually. Once the transmission is finished, SmartBeep compares the data to a known library of transmitters to identify the software version. SmartBeep then identifies an appropriate hardware picture for that software. This allows manufacturers to check that the right hardware and software have been united.
The hardest aspect of this project was that I was working to someone else's requirements. This meant that when I encountered a problem, I couldn't just move the goalposts to suit myself. My client's requirements were quite stringent in terms of cost and functionality. For example, during development I borrowed a receiver called a TR4 to detect the radio beeps. This costs $2,000. Because this receiver is so expensive, it is not economic for developers or manufacturers to have it tied up in the task of identifying transmitters. So I had to find a solution that was cheaper but still as accurate. I've hacked a $5 commercially available bug finder, the kind of thing neurotic people use to wave around their homes to check if they're being spied on. However, because this is something that only vaguely mad people buy, I could find no information on the internet about its internal circuitry or workings, so it took me a long time to fully understand how the circuitry works and how I could incorporate it usefully into my circuit.
During development, I discovered an interesting problem where at SmartBeep boot up, the pickaxe sometimes failed to complete the boot sequence while analog data was being fed into it. As the problem was complex and intermittent, it took me a long time to isolate. Eventually, I realized that as the bug finder is designed to pick up broad spectrum noise, it will detect any stray radio noise. Once this reaches a certain level, it caused a problem with the pickaxe boot sequence. This appears to be a generic weakness. You shouldn't try to boot a pickaxe micro while feeding analog into an ADC port.
To resolve this, I placed a resistor on the output of the bug finder to damp unwanted signals. I also added a relay to allow the pickaxe to turn on the bug finder after it is booted. Chasing this fault was important because transmitters are often being attached to rare and valuable wildlife that Doc has put many management hours into. I tested SmartBeep extensively and chased every bug and flaw until they were eradicated.
Again, because my invention is commercial, I had to ensure the user interface was intuitive. I did this by using a process of consultation, design, cognitive walkthrough, feedback from my stakeholder and redesign. For example, I originally placed the COM port connect button in the top right-hand corner, but this is next to the Windows close button, and during a cognitive walkthrough, I found my client clicked close by mistake. To remove this potential frustration, I moved the COM port connect button to the top left corner. I ran through the feedback process 4 times before I and my client were completely satisfied with the usability of SmartBeep. SmartBeep can currently identify all 23 different software versions of active management transmitters available in New Zealand. As new ones are designed by the manufacturers, they can be added to SmartBeep's transmitter database. I've created a website where manufacturers can download new software as it becomes available. The SmartBeep application checks for updates on startup, so users are always notified if their version is out of date.
There are 4 New Zealand companies who develop and manufacture active management transmitters. All of them now own and use SmartBeep. Thanks for watching.